it's important to know what the cloud is. And so kind of meme that's been floating around on the internet for a while that's completely true is what is the cloud? Well, here I have a nice picture for you that's meant to make a joke of it. And it's mostly a bunch of Linux servers that are floating in the cloud. And what the cloud really is accessing somebody else's computer remotely. So whose computer are you really accessing? One of the computers. It's part of the Compute Canada Federation. And we look after putting it together for you, right? So it's important to understand that there's a shift in how we do compute. So Compute Canada and the regions and the institutions that are kind of part of this project are historically tied more strongly to another form of computing, advanced research computing. And that is what I'm going to refer to as cluster-based computing. And on a cluster, there's lots and lots of computer resources that are available for a large number of people to use. What you do is you submit a program, typically we'll call it a job, and we'll submit it to that system. And it will then, the system will put you in line or a queue in order to use those resources. And when it's your turn or when there's space, so you can jump the queue because your job fits, even though the people with higher priority doesn't fit right now, it'll take you and it'll process you. So you are typically doing some waiting. It might be a few seconds, it might be a few days. If you have a really large job that doesn't fit well and you have a low priority, it could be weeks. So that's the cluster approach. And traditionally, that's been high-performance computing. The cloud is different. The cloud still has kind of a cluster of resources that are put together, but instead of waiting in line for a share of those resources and what share you have changing every time you submit work, on the cloud, you get carved out a small set of these resources for yourself. You're going to use those resources to create what's called a virtual machine. And this virtual machine is many things, but it's easily understood as a collection of CPU cores, memory or RAM, some storage, and then some software. And so it's almost as if you're building a personal computer that you might have on your desk, but you're building it remotely on our system. And that's why it's this remote nature that makes it referred to in some ways as a virtual machine. And so this is what we're going to show you how to use today and how to begin getting started with this by creating your first virtual machine, creating a security key in order to log into that virtual machine, then logging in, and then whatever's needed to do the security patches and updates on that box. So that's going to be our next step. So I'm going to put two URLs up here on the screen for you. The one at the top gives you more information about the cloud resources that are currently available at Compute Canada. And so if you were to type that link in, what you would find is a wiki page that's going to outline resources across the different sites. Compute Canada has a few cloud sites right now. So the largest of them, and the one that we're going to log into and use today, is called Arbutus. And you can see the link for the interface login for Arbutus on the bottom there. But we also have other sites. So each of our general purpose computing sites are our GP systems. So that's Graham at Waterloo, Cedar at Simon Fraser University, and Beluga, which is coming online soon at McGill. These will all have a small cloud attachment to them. And what this will do is allow people or researchers that need cloud resources, but also access to that cluster to work more efficiently together. There's also two historic sites that have been cloud almost exclusively. One of them is at Sherbrooke, and it's called Cloud East. And there is one at University of Victoria as well called Cloud West, although it's basically become Arbutus at this point. So at this point in the presentation, I'm going to swap from slides, which you've been seeing so far, and I'm going to move into a live view. Everything I do from here on in is going to be a live demonstration of building a virtual machine. I'm going to go reasonably slow. I'll be fairly pedantic, try to call out each thing I can so that you see what's there and the options that are available. Because we're trying to target about a half hour for this portion of the presentation, so there's lots of space for questions at the end. I'm going to skip a number of things that just aren't relevant for creating a first virtual machine. You can ask about them in questions, or you may see them in part 2 of the presentation, which is in 2 weeks. So I'm going to move reasonably slowly, but not too slowly. So I'm now going to swap over to the login. And this is the login that you would see if you went to arbutus.cloud.computcanada.ca. I've already put in my credentials, so I'm going to connect for the first time. What you can see here in the overview, lost my mouse pointer, just a moment here. So what you can see here in this overview is a set of almost entirely gray circles. The reason you're seeing that one red circle is because I did a demonstration yesterday and apparently I didn't fully clean everything up. But other than that, it will look exactly like it will if you were logging in for the first time with the most basic or the minimal amount of resources that we provide somebody who says, I just want to try the cloud out. Can I just have some basic resources, right? So we can see here that we don't have any instances running. And so instances is the way that this dashboard, which is an OpenStack dashboard, that's the tool that we use to provide this service. Instances are what OpenStack calls virtual machines. vCPUs, those are those virtualized CPUs that are pulled out of this pool of CPUs. I can have up to 4, but I don't have any right now. I can see that I can have 15 gigs of RAM, but I don't have any RAM currently being used. Floating IPs, this is a really nice feature of using the Compute Canada Cloud. This is the address that allows you to access to have access to your virtual machine from the outside world. You don't have to pay for that. That's part of the pool. Security groups, these are rules that say who's allowed to use your virtual machine, who can log in and how can they get access. Volumes, this is a total number of storage that's available to you in the cloud. And then we have the amount of storage that's available. All these numbers can be modified depending on your research needs. So, and you should see these when you first come in because the default view is under the compute panel here on the left, this overview. If we look underneath overview, the thing called instances, it's going to be empty right now because I don't have any instances. Again, an instance would be a virtual machine. There's another sub-panel. It's called images. If I click on images, it's also going to be empty. Images, oh, sorry, it's not going to be empty. Well, it is going to be empty. So images, these will be, it is not empty, my mistake. So these are all the operating systems that you can choose to boot from on the Arbutus system. You'll see that true to form, that little funny joke from before, what's the cloud, what are clouds made of, Dad? Mostly Linux servers. These are Linux flavors. If there's a flavor that's not here that you need, we can look into it. You should know as well that Compute Canada is currently talking with Microsoft, and we're making good progress towards being able to deploy Windows instances in the cloud. One caveat, if you're interested in that, most of what I'm going to go through today will not apply to you. There'll be a different way for setting those things up, we expect. The last subpanel under compute that I'll draw your attention to right now is key pairs. And what this is going to be a security access method, right? And we'll go through how to build this today. I saw a question come up in terms of what are the CPUs. We'll set that partially aside for when we're done this, but I'll come up to kind of how they're broken out in just a moment for that. If somebody wants to chat in on giving Scott an answer, that would be helpful. So basically, we've got this set of panels and these subpanels, right? We can also look at the volumes. There's some network information and some ways of coordinating things. And there's some information about me under the identity panel. We're going to skip all that for right now. What we're going to do is come back to instances, and we're going to build our first virtual machine. So to do that, once the panel is up,
1565.
on the far right-hand corner, there's a button just above the table that says Launch Instance. When I click that, I'm going to get a little window that pops up in my browser. It's going to give me some options. And what I'm going to be able to do with these options is build my virtual machine. So the first thing it's going to want is an instance name, and you can see my browser is being very helpful here for other things I've typed in similarly. So I'll just call this WestGrid Demo. And this is the name that's going to show up when you have that table of all the running instances. So this is an important thing for you to have because it's going to let you differentiate between different virtual machines that you're running. If you're going to be running a lot of instances and you have some naming convention that perhaps a set of numbers, or there's many people that are going to have access to your project, or sometimes your tenant, and that's a set of resources that you have as a pool, it can be helpful to have a description, but it's not required. I'll just say used for webinar needs a little bit of help here. Webinar on November. The next thing that comes up as an option here is your availability zone. If I click on this, you're going to see really 4 options. We're going to not choose any availability zone because that could put you in a zone that you actually don't have access to. And this is a possible hiccup for you in terms of deploying your VM, because if it assigns you a zone you don't have access to, then it's not going to spin up your virtual machine. We're working on trying to hide the options that aren't available to you, but it hasn't yet been configured to do that. The ones that we're interested in today are either persistent 1 or persistent 2. So partially to Scott's question about what types of CPUs are available. At the very highest level, there's 2 types. And one we refer to as persistent, the other we refer to as compute. Persistent are CPU cores that are shared many different ways. I believe it's 8 times. It might be as high as 10 times on Arbutus. And for those of you that are used to a traditional high-performance computing environment, this might seem kind of shocking because you're used to owning or having your own core. That's certainly the case on those cluster systems. When you get access to a core or a set of cores, you own them in full for a period of time. What's happening here on Arbutus and the other cloud systems, when you choose these persistent cores, is that they're part of a pool, but each core is also divided up a number of ways. Why is this? Because the persistent cores are meant to be used for deploying lightweight or medium weight in terms of the load that they receive web services. I'm assuming that you've seen academic websites and you know they don't typically see a lot of traffic. And so as a front end where not a lot of work needs to be done, it's a great use of resources to share them as many ways as we have. So we're going to choose persistent because the cores that we have access to without any fanciness, because we're looking at the basic allocation here, are going to be persistent cores. Now there's persistent 1 and persistent 2. The reason for this is that on Arbutus, it's possible for you to set up what would be known as a high availability system. So you deploy a server on persistent 1, you deploy another one on persistent 2, they're aware of each other and they could do things like load balancing. Or if the Arbutus team needs to take Arbutus down for updates or security patches and so on and so forth, they can take down just persistent 2, right? Persistent 1 stays running, they do all their patches on persistent 2, bring it back up, bring down persistent 1, and so your website is constant. It never goes down or goes away. As long as the site as a whole doesn't go down. So we're going to be using persistent cores. If you ask for it, and you have a reason for having it, you can have these compute cores, right? And so You can have cloud services that have full access to the underlying core. It is not shared with anybody else at all. So for today, I'm just going to choose persistent 1, but I could choose persistent 2 as well. It really doesn't matter. I also have the option here under the details panel to how many of these VMs, these virtual machines, do I want to spin up at a time? So you could build a whole lot and then modify them each. I only need 1 for today's demo, so we'll leave it at that. When I come to source, right, here you're going to see something that looks a lot very similar to the images panel that you saw before. So here's all the operating systems that are preloaded as images for you to boot your virtual machine with for its very first time. So I'm going to choose Ubuntu 18.04. This is Bionic. I'm not going to choose the minimal one because I don't know what you're going to do with this in the future. So if we install the full version, that'll be fine. People have different flavors that they care about. You're welcome to make your own choice there. So I'm just going to click the little up arrow on the right, and it moves Ubuntu 18.04 into the allocated piece, right? So I'm at the top of this panel, I'm booting from an image. That image I've chosen is going to be Ubuntu. If I click the up-down arrows under select boot source, I can see I can also boot from an instant snapshot. So if I already had a virtual machine running, I can take a snapshot of it. It's kind of a frozen picture in time of it. I can then take that picture and create a brand new virtual machine from it. I can also boot from a volume that's already existing, or again from a volume snapshot, a picture that's been taken. Beside this little window is the option to create a new volume, and by default it says no. So what we're doing here, what's being asked for here, and this is not directly apparent, so I want to draw this out really clearly, is do we want the volume to have its storage attached directly to the virtual machine, or do we want it separated off? If it's attached directly to the virtual machine, then its fate hangs in the balance with that virtual machine. If I delete that virtual machine or shut it down, then that volume is deleted or shut down. If I create it separately, then that volume is standalone, and I can get rid of that virtual machine in terms of cores and memory, and then create a bigger one and then plug it into that volume again. And so typically this is what we advise people to do, except for special cases. So I'm going to choose yes, create a new volume. Right? The moment I do this, it's going to ask me for a volume size. Well, I know that my max is only 40 gigabytes. We saw that on the first panel. I don't need to do a lot with this, so I'm just going to make a 20 gigabyte volume. So I'm just going to type in 20 there. And you'll also notice that on the right, I have a choice here. Do I want to delete the volume on instance delete? So do I want this volume, even though it's separate from the virtual machine or the instance, to be destroyed if I destroy the VM? And typically here the answer is no, and that's the pre-chosen option. But again, you could have it be the case that they're separate, but you delete the VM, you can delete the volume. So I'm booting from an image. That image is Ubuntu 18.04. The full version, I'm creating a new volume. That volume, I'm going to set a size of 20 gigabytes. The core thing here is that it needs to be big enough to hold the operating system plus any storage you want. You can expand the volume size later, but it's a bunch of clicks and it's a hassle. It's probably best avoided. So I'm going to throw in 20 and make sure that I'm solid. And I don't want to delete it after. The next option down the left-hand panel here is flavor. And so this is where you're going to choose persistent or compute. And you'll only see what's available here. So if you look down the left-hand column in this table of what's available, you'll see things like P1-1.5 GB. So this tells me, the P tells me this is a persistent core. It tells me that it's shared a number of ways with other users on the system. It's part of a very large pool of cores, and the cores themselves are also pooled. And it tells me that it's going to give me 1.5 gigabytes of RAM. Next one tells me it gives me 2 cores. Again, these cores are shared, and it's going to give me a total of 3 gigabytes of RAM. The next one tells me I can have 8, right, and 12 gigabytes of RAM. But you see this little exclamation caution sign here. It means that it needs more vCPUs than my quota currently allows. So that's hidden from me. So I don't need the smallest one. We don't need the biggest one that's available. I'm going to take this P2 3 gigabytes. So it's going to give me 2 cores, 2 persistent cores, and 3 gigabytes. And I'm going to click the little right arrow to the side. It's going to move the flavor up here, and it is now available for me. The last thing I need to do before I create this instance or this virtual machine is to do what's called creating a key pair. So key pairs are the way that we access the virtual machines. We don't do them, we strongly recommend that you don't do it through passwords. We certainly don't allow you to do it just through passwords when you first create the virtual machine. What a key pair does is it forms 2 very large sets of numbers. One of them, and characters, right? It's alphanumeric. One of them is the public key, and that public key you can use to lock things. The only way to easily unlock it, short of hacking things, is to use the private key, the key that was forged at the same time that the public key was forged. This is why it's a key pair. So we're going to drop out of the browser here for a moment. We're going to drop into a command line tool. We're going to create the key pair, and we're going to take that public key and we're going to copy it onto the server. That public key you can share anywhere. You can lock anything, you can give it to friends, they can lock things that only your private key can easily and quickly open. So that's what we're going to do right now. We can see that I've already built a key here, but we're going to imagine that I didn't do that. And so we're going to imagine that that key doesn't exist and that we're going to need to create a key pair. Now, there's an option to create the key pair here, but this makes it difficult or a bit of a hassle for you to get your private key off the system. So what we're going to do instead is import the key pair. Okay? And we're going to get this window. It gives me an option to name the key pair. So I'll call this WestGrid demo key. And it's asking me here to paste in my public key. But to do that, I first need that key. So now we're going to make a shift. And that shift is I'm going to swap from my browser view here to a terminal view or a command line tool view. So I'm going to do that, and then I'll explain how you might do it on your operating system. So give me a brief moment here to actually make that switch. Okay. Is it the case that you can see my...
We can see your terminal, yes.
Thank you. So, if you're running a Mac, the easiest thing for you to do is to hold down your Command key and press the space bar. So it's Command and space bar on a Mac. It's going to bring up Spotlight Search. You're going to type terminal or start typing terminal. You should see a little black box icon pop up. That's the terminal. And so you can click on that and you'll end up with a window that'll look similar to mine. You might have black writing on a white background or something different, but it's going to be the same sort of space. If you're running Windows, you're going to need to have installed a piece of software in advance. There's 2 tools that we recommend for this. One of them is Git Bash. So this is a tool that allows you to run Git, the versioning control tool, on Windows very cleanly, but it also gives you the power of a command line Linux-like terminal. That's one option. Another is to use a tool called MOBA Xterm. And so if you've installed MOBA Xterm, you can open MOBA Xterm, the program, and when that opens, on the right-hand side, you'll see a panel with a green button. It should say something like Start Terminal Session or Open Terminal. If you click that, in that panel within the MOBA Xterm tool, you will get a terminal that will look very, very similar to the one that you're seeing here. Both those tools, Git Bash and MOBA Xterm, put files in some different places and so on and so forth. So if you do create a key today, there's going to be a little work in terms of tracking where the private key is. But we'll still be able to create those keys today, and that's what we're going to do next. That's what we're going to do right now. So for us to create these keys, there are some commands that we're going to need to type. So I'm now back on my terminal window, and the command for creating a key of the type we're going to make is SSH, and SSH stands for Secure Shell. I'm going to put in a hyphen. There's no space here, and I'm going to say keygen. So this is the command to generate a secure shell key, a set of key pairs. I'm going to put in a space, put in a -T, and this is the flag that tells the command line or the key generation tool that I'm going to tell it what type of key that I want. I want an RSA key, so -T space RSA. So it's one of the security protocols, and so that's the one that we're going to use to produce this. And then I'm going to tell it what name I want to give my key. So I'm going to call this WestGrid demo. That's probably too much. Let's just call it cloud demo. Demo.key. You can call it whatever you like, but I like to put the .key at the end because it tells me that it's a key. I'm going to press enter. Apparently, I gave it too many arguments. Oh, you know what I forgot? Sorry. I'm going to type clear here. It's okay. It's good for you to see mistakes. So that's just going to move everything up so it gives me a blank screen. I'm going to press up on my keyboard again. You can see there's the clear command, and if I press up one more time, I'll get the command that I just typed. So that saves me typing. I'm just going to left arrow back. What I forgot to do was put in the -F flag before the name. The -F flag says what follows is the file name. So I'm going to run SSH keygen. I'm telling it the type with the -T flag. It's going to be an RSA key. And I'm telling it that the file name is clouddemo.key. And I do that with the -. It's going to generate the key pair. Now, this piece is important. You have the option to create a passphrase for your key. We strongly recommend, and to the point where we actually insist that you put a passphrase with your key. The reason is, if you do not put a passphrase with your key, then anybody who finds it can open your things. So having that passphrase is important. It'd almost be like having a passphrase with the keys to your house. If somebody finds the keys to your house and they know where your house is, they can just get in. But if they also need a passphrase and they don't know it, their house is more secure. We want your cloud servers to be as secure as possible, because it's a pretty wild west out there, and there's all sorts of attacks that are trying to happen all the time. So I'm going to put in a passphrase. It's going to ask you to put that passphrase in again. Once you do, yeah, I'm going to get a fail because I tried to cheat it. I need at least 5 characters. So I'm going to press up. Gives me the command to build that again. I'm going to run it again. I'm going to put in a better passphrase this time. And it's built my key for me. You also get this little rando art image, which is a representation of that key. It's supposed to be unique for your key. We have a fingerprint for our key. It's a very short version of it. I need to do 2 things still. One, I need to check and make sure those keys were built. Then I need to look and see my public key. So I'm going to run the ls command, and this is going to list all the contents of my current directory. If this is your first time using a command line, you might not have a lot here. I got a lot of stuff in this directory, so I'm going to run it, and we can see my files. Here at the bottom, this list of files that came up wasn't as bad as I was thinking. We have clouddemo.key, and we have clouddemo.key.pub. clouddemo.key is the private key, not to be shared with anybody else. Clouddemo.key.pub is the public key. So I now need to see what clouddemo.key.pub is so that I can copy and paste it. An easy way to do that is to use cat. Cat is the concatenate command. On the command line, it will print files out and stitch them together on the display. But we're just going to print out one file here, so it's going to print out on the screen clouddemo.key.pub, and then we can see the contents and print them out. So I want clouddemo.key.pub. And if I run this, there's the key. So it's going to start here where it says SSH-RSA, and it comes all the way down to the end of the name of my computer, which is simpson@simpsonmbpro.local. So I need that, and I'm going to copy it. So how you copy it is going to depend on your operating system. Maybe it's Control-C for you, might be Command-C. You might be able to right-click on it and choose Copy. If that's not going to work, then from the Edit menu in the top, you should be able to choose Copy. We're going to copy that key, and I'm going to drop out of my terminal, and I'm going to go back to the web browser. So just give me a moment here to make that swap. That swap should be done. Is that correct, Alex?
We can see the entire screen now.
Okay.
With the browser window.
Perfect. Oh, I see. You're seeing the entire screen. Well, let's swap that off so you get a better view. Make it easy to see.
Perfect. Yes.
Okay. Thank you. So what I'm going to do here is I'm going to come to this public key space, and I'm going to Control-V or Command-V or right-click and choose Paste, which is what I'm going to do here, or you can choose Paste from your Edit menu. And it's going to drop in this key that you just built. It's very, very important here that you're cautious or guarded against extra white space. So there should be nothing after the end of the name of your computer. There shouldn't be a space. I've just put a space in here. I'll delete that. That will mess things up because all of a sudden the key, which is exact character for character matching, is changed. If I put in a paragraph split, right? So I press Enter. It looks fine. It looks just like the same key. But again, that white space means different characters in your key, and you won't be able to access your virtual machine. So make sure that your cursor is flashing right at the end of the word local or whatever the end of your system is named. Once this is done, I've got a name for it. I've pasted in my key. I'm going to choose Import Key Pair. So we now have all the pieces that we need to build our virtual machine. We've provided the initial details, which is its name, a short description, its availability zone, and how many we want to build. We've told it what image we want to build. It's an image. It's going to come from Ubuntu. It's going to be 20 gigabytes. We're creating a new volume. We want this volume not to delete when we delete the virtual machine. We've told it what we want in terms of cores and memory. That's referred to as the flavor in OpenStack. So a P2, 3 gigabytes. We don't have to worry about any of the network stuff. That's all handled for us. We'll come back to security groups, but we do need the key pair. Otherwise, when you create this virtual machine, it won't have a way to access it, right? So this key pair is baked into the initialization, and it's this key pair that's going to let us access the VM. So we've done all of this, and so now in the bottom right corner, doesn't matter what panel you have selected, you should have the option to launch an instance. So we cross our fingers a little bit, and we click Launch Instance. It'll take us to the instance panel. Up in the top right, I can see there's a little green browser notification that said that you have success here. It's being built. It comes up. We can now see that it's doing block device mapping. So this is carving off a set of the the storage that's available on the system for us to use to hold our operating system and run it. Once that's set aside, it's going to spawn, and so this is going to be loading the operating system in that space and bringing up that virtual machine for us to have access to. While we're waiting for this to happen, there's two more things we need to do before we get in, and we can do them fairly quickly. The first one is we're going to need to, well, it's already up and running. We can see that here under its power state. So here's the name that we gave it. Here's its local IP address that's just within the cloud system itself at Arbutus. There's its flavor. This is the key pair that I'm using. It's currently active. It's not locked. You have the option to lock it on the menu at the right, which prevents it from being accidentally deleted or overwritten. What availability zone I put it in, what's its power state, and how long has it been up for. So the most important thing for us to do now in terms of accessing it is to access a floating IP. So if we click this little right triangle beside Create Snapshot, and again, those snapshots would be ways to take a picture of that VM at a point in time. It's a save state for it, as if you were saving a video game, for example. So I'm going to associate a floating IP. Now this floating IP is going to be the address that the outside world will use to access our virtual machine. When you come in here for the first time, you're going to see no floating IP addresses have been allocated. There's a very large pool of them at Arbutus. We haven't asked for one out of this pool. We know, based on the quotas we saw before, that we can have one. So I'm going to click the little plus sign to the right. I could put in a description and so on. We want it from the public network pool. We don't have to worry about anything here. It's also the only option. I can see here's my quota again. I've used 0 of 1. I'm going to click Allocate IP in the bottom right. And now here I have a 206 address, different from the 192. The 192s are internal. The 206s, these are the addresses for accessing from the outside world. And I'm going to choose Associate in the bottom right corner. Take a moment as it works away here in the background. And when it's done, what you'll see, as you can see right now, is here's the internal address. So if I wanted my virtual machines to talk to each other within the system, these are the addresses that I could use. And if I want to reach this virtual machine from the outside world, I need this number, this 206.12.88.252. Yours, if you're following along or you follow along in the video that will be released of this afterwards, yours is going to be different, right? Unless I throw this back in the general pool and you just happen to be assigned it, but that would be a little bit random. So I'm going to remember this, and by remember it, I mean what I'm going to do is I'm going to copy it, even though we're not going to need it for another minute or two. There's one last thing that we need to do in order to be able to access this virtual machine. And so that is going to be, setting up a hole in the firewall. We're going to open a port that's going to allow us to use the command line to access our virtual machine. So we're going to use a secure shell. That's why we have the secure shell key in order to access this virtual machine. But in order to do that, I need to tell this virtual machine that it's allowed to open the port that's needed to do that. And I'm going to do that down here in the network panel. So we're currently looking in the compute panel. If I click the network panel, there's an option here called security groups. Now, I hadn't fully cleaned everything up last time, so I do have a security group that I don't want right now. I'm going to delete it. We'll pretend it wasn't here. So to delete it, I'm just going to put a little check mark in the box beside SSH. If you were coming in here and it was truly empty, we would have default open. So I've clicked SSH, and I want to delete that security group. So I'll just pretend it wasn't here. You won't need to do this if it's the first time in for you. It's me not cleaning up. So you come in here for the first time. It's going to say default. You don't need to worry about it. We're going to create a new security group. And this security group is going to be purely and totally for SSH access, right? Secure shell access from the command line. It's the only rule that I'm going to deploy in this security group. So I'm just going to call it SSH. I'm not going to put a description in because this name is so descriptive because that's all it's going to do. And I'm going to choose create security group. So first thing we do is we name it and provide that description. Then once we're in here, so it's created it, but the exact rules that this group has in terms of what it's going to open and so on and so forth, that has not been done. So just because we called it SSH doesn't mean that that's what it's doing. We need to come over here under Actions and choose Manage Rules. And so here's just standard set of rules that are going to be applied. We won't go through what they are. They're not going to matter for you creating your first VM. If you're interested in that, one of our experts can walk you through some of the security pieces in the network that's going on there. But what we're going to do is add a rule. This is really slick and easy because it's going to give us most of the options we need already. All we need to do is choose the rule we want. And if we scroll down this list, you'll see here at the very, very bottom is exactly the port that we need to open, and that's the SSH port. So we choose that. What we typically recommend you do is that you restrict your IP address range. So I'm not going to spend a lot of time, I'm not going to spend any time telling you how to put in a whole range here, but I will suggest and I will demonstrate for you right now how you could lock down access to your virtual machine from only your IP address. We're going to do that by posting the IP address for our computer in this, what's referred to as a CIDR line, the CIDR piece here, right? And you can see this is a classless interdomain routing. So what address is allowed to access our virtual machine? Well, how do I get that address? I'm going to click on another tab that I've already opened. This is whatismyipaddress.com. You can just go into Google and type what is my IP address and it will tell you. And I've already got my IP address here. I'm going to take the shorter address here. It's called an IPv4. I'm going to copy that. I'm going to come back here to managing security groups. And in this classless interdomain routing panel, I'm going to paste my IP address. And so it is the case now that only my IP address should be able to access this virtual machine. That's a significant security boon for you. I'm going to choose Add. So now we can see port 22, which is the SSH port, is open. And then here is my address, right? It adds that /32 at the end, which is just more information for it, but I believe it just locks it down to that one address. So the last thing we need to do before we actually log in is we need to come back to our instance. So I'm clicking on the Compute subpanel. I'm going to click on the Instances subpanel, or the Compute panel, sorry. And all the actions on the far right side, I'm going to click that down arrow. And what I want to do is I need to edit the security groups. So we're going to leave the default security group here. We're never going to touch that. It's got important things that shouldn't be messed around with. And we'll leave the SSH group as is because we just built it. But we're going to click the little plus here, and it's going to move it over to the right-hand side. So it's now part of the instance security groups. I'm going to press Save.
I think your mom's outside, brother.
We now have our fully built virtual machine, or as OpenStack refers to it, our fully built instance. What we need to do now is log into it. So to do that, we need to swap back to our command line or our terminal. And I'm going to make that swap right now. Just give me a moment to do it. should see the terminal window again. I'm going to type clear just to get rid of, it's just going to move up the prompt so that it looks a little cleaner for us. It should be easier to follow along. And now I need to access that virtual machine. So to do that, this is the command to do it. SSH, there's nothing that comes after it now, just a space, right? I need to tell it what key I want to use. There's a number of fancy ways to do this, but given that we built the key in the current directory where we are, we can access it directly by passing it the identity flag. So we're going to tell it what key I want to use, and that key, I've forgotten what I called it now, I'll call it cloud demo, right? So SSH space -I cloud demo dot key, and it typed really fast there because I pressed tab. It saves me typing it incorrectly. So it can find that file in the folder that I'm in right now, and so it will complete the name for me by pressing tab. And now I need to tell it where to go. Well, and a username. So I built an Ubuntu system, and the standard username on Ubuntu systems is Ubuntu. If you choose one of the other operating systems that were available, for example, CentOS, you need to know the username for that system. And if you're not sure, you can ask the cloud team or send an email to support@computcanada.ca. So SSH-I, then the name of my key, the username for that system, and then I have to give it the address. So Ubuntu and then @ and if you remember before, when I saw that floating IP, I copied it right away. So I'm going to paste, when I failed to paste my, sorry, wrong key there, cloud demo.key Ubuntu @ and it's not the right address, so let me go back. I grabbed the wrong one. So I'm going to go back to my browser window, which you're not going to be able to see here, and I'm going to copy that 206 address. And then I'm going to paste it in here. And I'm going to press enter, and if all goes well, right, it's saying it's never seen this host before. Does it trust it? I'm going to say yes. Press enter. It's adding that list of hosts to the list of known hosts on the site, so it will trust it in the future. It's now asking for that passphrase that I created with my key, so people couldn't just steal it. I put in that passphrase. We see a whole lot of information about the system fly across the screen, and we now have this green prompt, Ubuntu at WestGrid demo. Again, there's the name of the system that I created, and we're logged into the virtual machine. And so this is almost as far as we wanted to take you. I have one last recommendation for you to do, and that is as soon as you create these virtual machines, you should update them in terms of the list of packages that are available on the system, and then immediately upgrade them so the most recent security protocols are being deployed. So the last thing I'll do is just quickly show you how to do that on Ubuntu, what that looks like, and then we'll swap over if any of you want to hang out for a few minutes. I know we're almost at the hour. Some questions. So Ubuntu is apt-get, so it stands for aptitude get. It's an operating system update the set of all the tools that are available. I need to tell it that I'm the super user, so I have to say sudo or sudo at the front. Ubuntu systems have what's known as passwordless sudo, so you don't have to have a password to become the super user. You can just type it in. It's another reason to make sure your VM is locked down if you're going to use Ubuntu especially. So I'm going to say sudo apt-get update. It's going to go and grab all the new sources and programs that are available from all the libraries that are floating around out there that the system knows about. So you can see that happening on the screen right now. This is typically pretty quick. And once that's done, which is now to update, I'll say sudo apt-get upgrade. So when I run sudo apt-get upgrade, it will then apply all the changes in the patches. And with that, that brings us to the end of creating your first virtual machine in Compute Canada Cloud.